Today we're going to be doing Chapter 4, Lesson 8, Quadratic Functions. You're going to learn how to graph quadratic functions and know whether the graph, which is called a parabola, opens up or if it opens down. You do this so you can compare functions. How will you know you can do it? You'll be able to graph a quadratic and know when looking at the equation whether it opens up or opens down. So your vocabulary, quadratic function. It's a function in which the greatest power of the variable is 2. For example, y equals 3x squared plus 4. This is a quadratic. Or y equals 3x squared plus 2x plus 4. When you graph a quadratic, you get something called a parabola. That's what you see here in these two pictures. One is the graph of a positive quadratic equation. X squared is positive, it opens up. When x squared is negative, it opens down. So positive x squared smiles, negative frowns. So if you were to graph a quadratic function, you would make a table and you would choose both positive and negative numbers for x. Now you would do this unless the numbers for x being negative don't make sense. Like for instance, if you're doing time, since time can never be negative, you would only use positive numbers. Once you pick your values for x, your domain, then you will solve for y. You'll connect the dots and you'll end up with a parabola. So in this case, the graph of y equals negative x squared plus 4, we know it, since it goes right here plus 4, that's the y-intercept, so over 0 up 4. We know it's going to frown because it's a negative in front of x squared, and then we put in the numbers negative 2, 1, negative 1, 0, 1, and 2, and you do the math. And if you'll notice, negative 2 and positive 2 both gave you 0. Negative 1 and positive 1 both gave you 3. So you should, once you know what the line of symmetry is, the point at which you can fold the object in half and have the two sides match, once you know what that is, every point to the right, up or down from there will match. So let's do one. We're going to graph y equals 6x squared. We're going to pick values for x. So we're going to pick negative 2, negative 1, 0, 1, and 2. Why do you pick small numbers? Because since they are squared, they're going to get big real fast. So this will be 6 times negative 2 squared, 6 times negative 1 squared, 6 times 0 squared, 6 times 1 squared, and 6 times 2 squared. Negative 2 squared, that's negative 2 times negative 2. That's positive 4. 6 times 4 is 24. This is also going to be 24. 1 squared is 1 times 6 is 6, and negative 1 squared is also 1 times 6 is 6. And anything times 0 is 0. So now you can graph these. The 24 is going to be hard to graph because it's not going to fit on our graph. So we are going to focus on graphing these 3 points to draw our parabola. So we are going to go left 1, up 6. It's going to go through 0, 0, and right 1, up 6. The number in front of x squared is positive, so we know it's going to smile. And you will draw your parabola, which would look something like this. Now you want to make sure your lines go beyond the points. And yes, it does kind of look like a face with the eyes here and the nose here, but this is how you graph a parabola. Okay, so here we've got a situation where we have a function, d equals 16t squared. It represents the distance a skydiver falls in seconds, t. We're going to graph the equation. We're going to use the graph to find out how much time it takes for a skydiver to fall 400 feet. Okay, since we are not actually starting at a given point and dropping, we're just talking about how many feet difference there are, we're going to use just positive numbers. So we'll start with 0, And then we'll go 1, 2, 3, 4. So 16 times 0 squared, 16 times 1 squared, 16 times 2 squared, 16 times 3 squared, and 16 times 4 squared. So this is 0. 16 times 1 squared would be 16. 2 squared is 4 times 16 is 64. 3 squared is 9. And 9 times 16 would be 144. 4 squared is 16, so 16 times 16 equals 256. Okay, we've got a graph, but we don't have 400 feet yet. So let's go one more. So this would be 16 times 5 squared. That's a funny looking 5. So that would be 16 times 25. And that would be 400. So we know what our answer is. To graph this, we start at 0, 0. You're going to go over 1 up 16, and since these are all 100, 16 is going to be real low. Over 2 and up 64. Over 3 up 144. Over 4 and up 256. Up 5 and up 400. And you can see that it looks something like this. And you can tell 400 feet is right here at 5. So it would take 5 seconds for a person to fall 400 feet. So let's do another example. This one is on page 338. The outdoor observation deck of the Space Needle in Seattle, Washington is 520 feet above ground level. Use the graph to estimate how far you could see from the observation deck. So in this case, we're just going to look at the graph. We want to go to 520 feet. This is feet. So 2, 4, this would be 500 here. 520 would just be slightly above that line. So we're going to take this over till we get onto the blue line, and then we're going to come straight down. I could draw straight. And we can see that this is 25 right here. So it's between 25 and 30. So you have to ask yourself, is it closer to 27 or 28? So it's approximately 27 to 28 miles. How do I know it's miles? It says distance in miles right here. So you're giving your best estimate. If you could draw a straighter line than I am, good luck. So we can use the graph of a quadratic to answer questions that are being asked of us. That's it, ladies and gentlemen. Let me get this clear so you can see. Your assignment is on page 339, 340, problems 1 through 11. All right, good luck with this.